Hi, everybody. Welcome today for part two. It's very exciting to be here. My name is Craig Voisin. I'm one of the co-leads within the Dury workstream of GA4GH. I'm joined here today with Mikhail Linden, who's also heads up part of the some of the specs that get implemented as part of Dury in GA4GH. So this is going to be the technical deep dive. And yes, so let's maybe go to the next slide. We're having a few technical difficulties, so there'll be a little more chat about next slides on this presentation. Yeah, so I just want to introduce, of course, the GA4GH is the Global Alliance for Genomics and Health. For those who aren't familiar, it's a policy framing and standard setting organization in the genomics data sharing space. So if you're not familiar, there is a link or a URL on the bottom of all the slides, ga4gh.org. So I invite you to check it out and learn more about the organization. All right, so let's start with an overview of the webinar. So we're going to break it into 4 acts here. The first part is going to be the system actors. So we're going to discuss what are the different components involved and how do they kind of fit together more or less, and some of the options with configuration as well. The second part is going to talk about OIDC flows. So we're going to get into some of those nitty-gritty details, and there'll be the components and kind of the flow that's involved, as well as some of the authorization checking options. And with that, that'll segue into more security pieces near the end. But first, we're going to introduce what are the internal workings of the passports and visas. So we'll be looking at the access token format for the passport itself, as well as the visas, which are also tokens, and what they look like. So that's the overview. Okay, so before we get into the technical details, just wanted to pause here for a moment and talk a bit about the context of this webinar. So there are many different ways that these technologies could be applied. And so I just wanted to say that although we'll be discussing some general strategies, a lot of these strategies have to be adapted for the particular scenario and use cases that are in play. And moreover, the overarching theme is around how the technology and policy fit together. So policy is really important. And so these technologies need policy to make sense and fit with these technologies overall. And if you just click forward. So the summary is the technical solution is not enough. You need to have the appropriate systematic policy adoption to make these kinds of solutions feasible. So we'll be discussing a bunch of the technologies and different options today and how these things can fit together, but within this context of assuming that the policies can make sense for these options. All right, so let's go into the relationship of system actors. Okay, so if we just forward one, we'll see that here we represent the organization for which a DAC is operating on things. And so this is a source of authority that can grant access to data. So next one. And there's the data sitting over there. So there's a bunch of stuff we're going to show in the middle here on connecting these things. Next. So the first piece is when a DAC makes a decision, we'll look at it from this perspective. There are other types of visas, of course, but when a decision gets made, such as the DAC, obviously they need to store that decision somewhere that somebody should have access. And so let's refer to that as a passport visa assertion repository. So far it's an assertion that, you know, some user has access to something. And these things are covered by the specs, specifically the AAI specification, which is the authentication and authorization infrastructure specification that is formed by GA4GH. It's all built on other standards, of course, but there's just a little bit that talks about this piece. Next. But in general, the communication protocols and how this information makes it from someone who makes a decision or a group of people who make a decision and it lands inside this repository or this database, that's not within the specs. So this is up to the individual system. And if you're working with existing systems, probably the way that works today wouldn't need to change, perhaps at all. So that's just laying the foundation for the fact that there's a database and information is there in some format. It does not have to be in a visa type format. It's just the assertion. Next. There are other actors who can also participate to the same repository. They may not be the DAC. They could be other people within the institution, such as a signing official. They could be across different institutions. This could be a repository for a whole group of things, such as you might see with ELIXIR in Europe, or dbGaP perhaps is an example with NIH. You can have one repository that stores things across many different, with many different actors contributing to those assertions. And those assertions can have different flavors as well. They're not all DAC related. Next. So once that stuff lands in the database, the question is we need to get it towards the data where a user is going to start using it, a researcher is going to use it. So here we are going to introduce the Passport Visa Issuer Service. And the role of this piece is specifically to take the information out of the database, format it in a GA4GH passport visa compliant way, sign that particular visa so that we can check authenticity later when we need to. We'll talk more about that later. But there is a role there in the service that can do this. And that's where you end up with the standards really coming into play in terms of what the format is. Next. However, the connection between the database and the visa issuer is not part of the specifications. It's unspecified. It can work in many different ways. It might be a database SQL query. It could be pulling it out of a flat file. Whatever that thing is. But the point is that a visa issuer service is where it starts to become in the format as per the specs. Next. All right, the next phase of the chain here. So we have the passport broker. The broker itself doesn't have to create visas or anything else. That's the role of the visa issuer. It's possible that a broker can create do some issuing itself, in which case these two things kind of blur for particular types of visas. For example, it might be related to your identity. When you log in, it might want to make some kind of assertion. But in general, we're going to show them as separate entities here. And so just next. The relationship between these two is, again, not specified. So the broker is going to have some way that it can log users in and then ask the visa issuer to issue visas related to the user. And that is, again, up to the particular environment and what makes sense and the different technology stacks that are being used. But it's the broker then that becomes the face of these particular assertions that are now wrapped in visas and now attached to a passport. So this is where the standards really come into play. Next. And that's when you want to have somebody use this visa, these visas on a clearinghouse. And so the passport is a wrapper, basically it goes around the various visas and gets delivered as a token. Next. And this is where the standards really dictate how these things interact. So the protocols here are very specific. It's using OIDC, a bunch of flows there involving the user. There's releases of information and so on that happen here, and it's multi-step. And the specs will lay this out in detail. So this is where these things get across these boundaries between organizations, especially where this is all according to specification. Next. Of course, the clearinghouse itself it can be a service, it can be a process, it could be just grant other types of access related to a specific data set on a particular cloud. This is also unspecified, and it really depends on the use case. We'll give several examples of different types of clearinghouses that could give direct access to data. It could be a service that does a search for you. All those things are depending on the particular use case. There could be some standards there. So if you're using a GA4GH standard on how these things might interact, that's definitely possible. But in general, from our perspective here for the passports, this is unspecified, and it's really up to the clearinghouse how the data is formatted and what the protocol looks like between these two players. Next. Okay, and even how these things are related, I'm just putting a dotted line between the cloud with the data and also the passport clearinghouse. They can be deployed together in some way. The relationship there is also unspecified. Next. Now, keep in mind, we followed this through. So a user would have picked up their passports. They'd be involved where the broker is, kind of in the middle. And they've pulled all this information forward into a clearinghouse that made an access decision, and that lets that user do some kind of data interaction. But along this entire path, we need to have some kind of data governance and policies in place that make sure that the issuing organization that owns the data or controls the data understands how these things are flowing and has some control over making sure they're done according to various policies. Next. And the last piece, of course, is identity. So all these different systems could have different logins and different ways that users identify themselves. There's also a bunch of different users with different roles, such as signing officials, DACs, and researchers themselves. And so all of this needs to be managed along this pipeline as well. So these are just an introduction to the various components. I invite you to visit the specification there to learn more about it. Next.
Hey, good evening. I'm Mikael Linden from the Finnish ELIXIR node, and in ELIXIR we operate one of the passport brokers. It's called ELIXIR AAI, ELIXIR Authentication Authorization Infrastructure for the ELIXIR community. One of the cornerstones of this passport architecture is that a passport can contain visas from several sources. And in this diagram, we can imagine that the passport broker pulls some visas from EGA, the European Genome Phenome Archive, for controlled access datasets to describe a user's or researcher's data access permissions to controlled access datasets at EGA. But it can also pull some visas from other sources like the internal sources of ELIXIR, and then present those visas to the passport clearinghouse for access control enforcement. And the syntax of the visas is JWT, so it has a signature that comes from the visa issuer, and that guarantees that the visas are immutable. So the broker can decide to include or exclude some visas in the passport, but it can't change the visas when they come from the issuers. This is an example deployment. The visa assertion sources are the data access committees for controlled access datasets. And the DACs themselves can be the issuers of the visas as well. However, what we can see is that quite often the datasets themselves are deposited to a data archive like EGA. And because EGA is the place where the datasets are stored, it has also authoritative information of the datasets, data access permissions. So it's quite natural that the visa issuer is at EGA as well. So the issuers deliver the visas to the passport brokers, for instance, ELIXIR AAI, CanDIG AAI in Canada, and also NIH is planning its passport broker service. One of the features is that the passport brokers can interact with each other. So they can exchange passports and visas inside the passports, so that the relying services need to integrate to just one broker. And actually last week we demonstrated the interoperability of ELIXIR AAI and CanDIG AAI in the Geneva project, and we were able to pass passports across the Atlantic. The passport clearinghouses consume the passports. Some of the passports can be consumed by the cloud workstream products like DRS service, but also beacons can consume passports and use them to enforce access. It's possible to have controlled access beacons, but a logical application of passports and visas in beacons is to use registered access. For instance, the piece of information that a particular person is a researcher in their home organization. And that kind of information can be conveniently received not from data access committee, but from the home organization of the researcher, potentially when they log in using their home organization credentials. So that ended the system component introduction, and let's next dive into the details of OpenID Connect or OIDC, which is the main protocol for shipping the passports back and forth. So in this diagram, you can see the same components that were in the previous slides. There are the visa sources, which are data access committees for controlled access visas. The passport broker is here in the middle, and the passport clearinghouse down here, which is the component which consumes the passports and enforces access to controlled access data. The new component in this diagram is client, and it's a system component that actually wants to call an API and access and present the passport to the API to access the services that the API provides. It can be a proprietary API, but in the context of Global Alliance, we of course assume it's one of the Global Alliance APIs. And the client is the tool, the workflow, the pipeline system that wants to make use of Global Alliance services. So it is a component that takes the first step to initiate the interaction with the broker and the upstream visa sources. It starts the OpenID Connect flow to receive an access token from the broker, and then it passes that access token and attaches it to the API call when it wants to use some of the Global Alliance products. For instance, there's a short list of some Global Alliance products here which use or potentially could use access tokens to authorize the API calls. And the Passport Clearinghouse receives the access token and then contacts the passport broker's user info endpoint to pull the visas that belong to that passport, validates the SWOT signatures in the visas, and enforces access to the controlled access data. So the next slide focuses on this interaction that the client is doing in the OpenID Connect. So it's, well, maybe the most detailed slide in this webinar today. So here we have the client again, and the passport broker and an API. In this example, we use ELIXIR AAI, but it can be any passport broker. And the passport clearinghouse, so the Global Alliance API is a beacon. And in this diagram, the browser is used for passing the communication between the client and the passport broker for the first two messages. And the first message is that the client redirects the user's browser to the passport broker's authorization endpoint, basically asks the broker to authenticate the user and asks the user to approve the release of the Global Alliance passport from the broker to the client. It indicates the flow type is authorization code flow, which is the basic flow in OpenID Connect, and also indicates its own identity using its client ID that it has received from the broker beforehand. When the user is authenticated and approved the release of the passport, the passport broker passes the browser back to the so-called callback URI of the client and passes a code, authorization code, in that browser redirection. And then the next sequence in the flow is that the client sends the authorization code to the broker's REST API, and in exchange, the broker delivers the access token to the client. And now the client attaches the access token to the API call usually the authorization header of the API call, for instance, to the beacon API call. So this is how the basic flow of OpenID Connect goes. It's the ordinary flow of OpenID Connect, nothing special from the client perspective. And back to you, Craig.
Great, thanks, Mikhail. So let's take a look at the different possibilities of trying to get the passport control service, the clearinghouse portion enabled in various different stacks. So if we could go forward. So let's take a look at the first option. So one option is you might have an existing service, or you might be planning a service, and you might want to integrate the passport control straight into that service. So go forward. So what would happen is the researcher would be using their tools, their clients, et cetera. They would be passing these things in. And as we saw, it's actually a couple interactions. So here it's a summary, just showing that it's all of those interactions occur. And at that point, the passport control would be able to check. You'd be able to create an authorization check to see whether it makes sense for the type of request based on policies that you would encode, that you're looking for the right visas. And then it would, your service then would do whatever it normally would do, interacting with data, and pass back, go ahead, pass back a response and get the data, the response back to the user. So that's option A, is integrating it straight in. And if you go forward, there's the one thing I just want to point out, which is some of the overhead of this step. So what happens, as you saw when Mikhail was demonstrating it, there's a couple different calls that need to be made when you receive a passport and you want to do an authorization check. One is you'd have to check signatures and validation. So you have to grab a set of keys, and we'll talk a little bit more about that later, but the signing keys would need to be checked. Then you need to make a call back to user info endpoint to grab the visas. And then you need to rummage through the visas and apply a bunch of policies. So there's a bunch of validations, multiple steps to validate on every API call that comes through here. Let's take a look at some other options. This can make sense depending on the volume. But the second option you might have is you could still have your passport control. But in this case, if you forward, the call will go into and get approved multi-step through the passport control. And then that passport control can, through some mechanism, kick off existing services that are in the back end. These services could look very similar to what we talked about before. It could just be a simple endpoint, or it could be that it runs an entire workflow and does a long-running operation and comes back hours later with a response, either in band or in this case, if it's hours later, probably out of band, such as a file. And so that's another way that this interaction could play. And you can imagine if you had a proxy that you want to put in front of a service that would fit this thing, this particular scenario, or there might be other external reason to have an external service that kicks off these things. A WES workflow could work this way, for example, but doesn't have to. There's other ways as well. So if you look at the overhead here, you still have this multi-step validation, but now it's again, it could be more looking like the first one, but it can also work for long-running operations. So per long-running operation, that could run for hours. And so that's another option of how you can assemble these. Third option is the user would send a request to a service that would check it. And that service, integrated or not, would then issue some other type of key. It could be a cloud native key or a particular key for a particular service, and it's no longer a passport. So you use the passport to decide to mint another type of token that the user can use for a period of time. My analogy is the hotel. So when you check into a hotel, you can show your passport, and then they can give you a room key, and that room key might be valid for a couple of days while you stay. Now what you see is that the researcher using that key, they're now right next to the data or other services, and they're using the data directly. And so in this particular case, this enables certain use cases where you can't always include a passport clearinghouse because those services you want the user to interact with directly. There's not a good place to put it, so you can allocate the types of tokens that those services use. It also lets the researcher use whatever tools and stacks that they want to use directly on the data for some period of time. So now you only have the overhead one time or occasionally if you want to revalidate every day or whatever the period might be. But now, depending on how long this is and how long you let the user interact with the data, you have to go back to the policy side of the organization and say, what's the risk factor? If we give access for 7 days on some type of token, whether or not they have refresh tokens and access tokens there, do we need to have a policy so we can revoke that access? So you need to make sure that there is some policy where you can continue to check in some means, and we'll talk about those later, to see whether the visas were redacted in some way, so they're revoked, and then apply those things to that environment. So it depends on policy, but that can be some of the overhead and complication with the solution. So those are just 3 options. And they're examples only. So there's lots of ways you could piece this together. Even the middle example could use keys in the interaction between the service piece and the data. It can have its own keys or user type keys. So there are ways to mix and match these. These are examples only. Next slide. So now we're going to talk about the passport and visa structure. So let's start by just looking at an access token. This is a passport access token. This is what the format looks like according to the AAI specification. What makes this not just a regular AAI is that it specifically has the scope GA4GH passport V1. That's a signal that this is actually a passport. And what you end up getting out of this, you can picture it as a key, if you will, but it's a very specific type of key. Now it's a GA4GH passport access token key. And if you forward that one more, and that can get delivered. Think of it as almost like it's a delivery that's happening where it gets delivered to various services from wherever it was generated. And with that delivery comes some kind of guarantee. So if we look at the expiry date that's included in the passport token itself, it has, think of it as like a use by date. The delivery has to be within that time period. If it's longer than that, it could mean that maybe it's a replay and someone has captured it, it's at more risk. So you might want to keep this delivery time span short, and you're going to use this token to deliver the underlying messages. Next. So underneath this is our visas. And so that's what's being delivered by this package is we have these visas. They also have expiries. And so notice that the expiry could even be longer than the package guaranteed delivery. And so there can be multiple of them that have different best before dates, if you want to look at it that way. So how do we interpret this? So one is that if the expiry date on the passport token, if it's past the expiry date, you shouldn't even look inside and access the visas. It would require the user to come back with a fresher passport. Whereas once the messages are delivered and these permissions are applied for these different data sets or different things that these visas represent, they can live for a longer time once they're in that environment. And it's up to the policies to decide what's appropriate. What's the difference between a 3-month and a 12-hour really comes down to policies, risk factors, technology stacks, et cetera, that would set those time limits with those internal visa expiries. And that visa expiry tells you what's the latest time when I should start revoking access to the underlying resources. It's not a guarantee that it'll complete by that time. It's hard to make guarantees on computers, but it's when that revocation will often begin, and it will start pulling access to the resources if that visa was used for some purpose. If it's not, it can be ignored. Next. Okay, let's take a look at our passport with visas inside. So this is kind of the higher level image that we look at. If we look here inside the top visa, you can see it's actually constructed of a few fields. We'll get into those in a minute. I'm just going to highlight the high level pieces. You have a couple of fields that represent the visa identity of who the user is that we're interacting with. And you have a big block, which is called a passport visa object, which has a bunch of controlled vocabulary on what an authorization looks like. This is the standardized block that can be used across different implementations. At the bottom is the signature that represents that this thing can't be tampered with because of the encryption quality signatures that are included. Next. So if we look inside of it, this is really what the visas look like when you call the user info endpoint. They're encoded, and each one will have a couple of different parts to it. And so one visa represents one long string in this array. And if you forward one more, and the bottom one here can be represented, again, it's truncated here because it gets a bit long. But again, it has the different pieces as a long string. And you can see that the pieces line up as a JWT. The first part is the header, which contains certain information that we'll get into later. The middle part is the payload, which is the various different visa object fields along with some other claims. And the last part is the verifying signature. Next. And with that, back to you.
Okay, this slide introduces the 5 visa types the Global Alliance Passport Specification defines. The first 3 of them describe its holder's role. The affiliation and role visa signals that this person is, for instance, a faculty member in their home organization, and that can then grant them additional privileges in some passport clearinghouses. The next 2 visas, accepted terms and policies and researcher status, are used for registered access tier services. The accepted terms and policies visa indicates that this person has made the attestations for registered access. For instance, that I will refrain from trying to identify individuals from the samples I get access to. Researcher status role indicates that this person is a bona fide researcher in the home organization. And next one is for controlled access, and the controlled access grants visa is simply an indication that a data access committee has approved this person's data access application, and he or she is permitted to access a controlled access dataset. For instance, the EGA dataset identified here. And the last visa type is for linking identities and identifiers. It is possible and likely that the person is known with several names or identities in different services around the internet. And this linked identities visa simply indicates that these 2 identifiers belong to the same person. And the visas have also, the visa object has also a couple of other fields. And the first row is the type of the visa, one of those 5 types in the previous slide. However, it's possible also to introduce custom visa types using the Global Alliance visa format. Value is the actual value of the claim, for instance, the definition, reference to the definition under which the person has made the registered access attestations, or if it's for controlled access grants, the identifier of the data object to which the person has the access right. Source is the source of the visa. For DACs, for controlled access grants, it is the DAC identifier. For other kind of visas like the role and affiliation visa, it is potentially the home organization of the person. Asserted is a timestamp when this visa was granted. For instance, the timestamp when the data access committee approved the data access application. By is an optional field. It indicates what kind of entity or authority the source field represents. Some attestations are done by the researcher themselves. For instance, the attestations for registered access. Also, peer researchers can vote for a person's status as a researcher. System components can make some assertions. SO means the signing official in the researcher's home organization, and DAC stands for Data Access Committee and is relevant for the controlled access grants visas. Then there's one more field, which is the condition field, which can define extra conditions that need to be valid for this visa to be applicable. For instance, it's typical for controlled access grants that they are granted in the context of the researcher's employment. And if the person departs from their home organization, the visa isn't valid anymore. But those dependencies refer to other visa values in the passport, like the role and affiliation visa. So here's just an example of visa where the JWT is now decoded and the signature and header is dropped. Here is the visa object, so it's a controlled access grant, timestamp when it was asserted, and it defines access rights to an EGA dataset. And the source of the visa is the data access committee identified by EGA. The visa also has the issuer field. Yeah, this visa is issued by EGA. And the sub, which in this case is the user's EGA identity, which can then be linked to, for instance, the ELIXIR identity in linked identities, in other linked identities visa. The JWT has an expiration date and issued at date and JWT identifier, and then the identifier of the one who has signed the visa. And then back to you, Greg.
Great, thanks. Okay, so we're going to now discuss a couple different choices that are made by someone creating a visa. So a visa issuer gets to choose between provisioning and policy choices. The first one is an embedded document visa. So this has an immediate contract, an immutable contract with an expiry date. So think of it more like a decree, a royal decree that can't be withdrawn. It's valid for a certain length of time. And there are use cases for that. So we'll talk about that in a second. The second one is the embedded access token visa. So this is a slightly more powerful token in some ways because you can issue it and then you can also revoke it. But it also requires extra endpoints. Let's compare the two and talk about what are kind of the pros and cons. So first thing is, how do we identify between these two things? So one thing is what the issuer does is they would put a JKU in the header. So if they have the JKU, it indicates that it's an embedded document visa. And it only needs to distribute the public key. It could use, of course, it'll do that using the JKU, which will point to where where you can get the public key for this particular visa. But of course, I know of a case where someone's looking at also distributing keys out of band, but it's the signal. Whereas if we look at the embedded access token on the other side, it does not have the header. So that's how both the person creating the token and the person reading the token, how they can tell the difference. So with the embedded access token, now you need to implement more OIDC endpoints as the issuer. And you can then use that for revocations. There's an introspect endpoint, or there's a user info endpoint, and these kinds of things that can be used to tell whether tokens are still valid. So the pros of that, of course, is that it's a lot less risk for longer lived access, because you can always issue a longer lived visa and then revoke it if you detect that someone isn't behaving according to complying with the various standards. However, there's also cons, which is not only do you need to stand up a little more infrastructure, because you do need to build out more of an OIDC full system, but also it's more complex downstream because there are rules involved with these tokens about checking for revocation. And depending on those other options I showed earlier, there can be layers of this where a user's using certain access and you have to keep monitoring whether or not it's still valid, and then you need to apply it. If it gets revoked, you need to pull out the underlying access in the various clouds. So it is a little more complicated all around for use, but it has a little more power. Whereas on the other side, if you're an embedded document visa, it's very simple to both mint and check. It's valid for a certain amount of time. But the cons there, of course, is that if you are doing longer term access, you want to think it through and verify with policy what makes sense, what's the risk factor for how long it needs to exist. So that's kind of the trade-offs. It's totally up to the issuer to set how this is going to work by the various signals they put into the visa. And then it's up to the clearinghouse that they follow the rules according to the way that it was created. Next slide. Okay, let's talk about various security implications of a lot of the stuff we've discussed. So one, let's first look at the passport access token. This is that thin token. One is not so sure we should have a JKU there. Definitely shouldn't just follow it blindly. Obviously, as a rogue actor, I could pretend I'm EGA and I could simply add a JKU to point to my own service, and you would use my key to verify that I'm EGA, but of course it's not the real key, it's just the one I use to sign this thing, and that's a serious security problem. So not so sure you should even use JKUs on these things. Probably reject. Definitely it has to be something on a whitelist or something if you're going to be using them here. Second, but the JKUs I talked about earlier are not for these tokens, they're for the visas. Okay, so next one is checking these various things in the header. So make sure the type and the algorithm are according to spec. And then following, we have keys. Of course, you can cache keys, but you probably shouldn't cache them for long. People can revoke keys. You should be checking back every once in a while to get the keys again from the OIDC provider. And if it's no longer valid, then you can reject this. So now when you have the issuer, depending on the type of thing you're trying to enable, there could only be one issuer that you ever want to see here for that particular data set, for example. But it is possible, depending on the visa, that you might accept 100 different issuers across a federated network to do something related to, let's say, registered access. So here you would have an allow list that would let those things to know whether or not it would be accepted for your use case, for your policy. The subject field, not used really for security reasons, but directly, but it is used for auditing. So you can do some auditing, and perhaps if you're getting some kind of violations and you need to block somebody, that can come in handy either directly, or you can contact an upstream source and tell them who is behaving in a way that doesn't fit your policies. Next, we have the expiry. Of course, you need to check it versus what the current timestamp is to see if it's expired. The issued at and not before, these are other things you need to check compared to what the current time is, especially the not before, so that something could be valid in the future. Audience can be a list. I want to point out that doesn't always have to be a list. I think if you hit forward one, it can be another format, but you need to check. If there's an audience there, you need to check that it matches your audience. And we'll talk more about that in a minute. Has the GA4GH passport scope? You need to check for that there. And the IDP we're not using much, but there can be a token identifier with tokens, and that might be useful for audit logging and seeing for leaks as well, and disabling certain tokens from the various pieces of infrastructure. All right, now with that, the next one is the visa token. Okay, so let's go through this. Starting at the top, what do we have? All right, once again, we have a JKU, but this time we know that can be a signal for a certain visa provisioning. It's not necessarily that you should just trust it and walk through, as we talked about, but you probably want some kind of allow list to see whether or not this makes sense. And it might be an allow list for the particular issuer. Does this JKU make sense for this issuer? Next, of course, we're going to check those types and things up there again. And for the issuer, for this particular policy, we're going to be checking to see, does this issuer make sense? Does it have the authority to issue things for this particular data set or whatever is being requested? The subject, again, for audit logging can be handy. And we want to check that it's not expired as before, and also the issued at and not before, those kinds of things. And the audience, once again, if there's an audience, it has to match what your audience is for your particular clearinghouse. It's destined for you. And I just want to point out, I guess it was on this slide, I want to point out it's not always an array. Some of the older formats used a single string here, so you might need to be able to accept tokens that handle both arrays and strings, and just one string. Okay, so inside the visa block, of course, you're going to be probably setting up a policy that's looking for a particular type, and it must match. The asserted is interesting. Let's just pause here for a second. So a lot of times this isn't relevant to policies, and that's totally fine. But you could imagine if someone issued a a particular visa and said it's valid for 2 years. And someone's a researcher at this institute, I validate that for 2 years. But when you apply it and you really want to check, you might want to tighten that up a little bit. And if no human has gone back to recertify that recently, let's say every 6 months, you might want to have a policy. This allows these kinds of extra security checks to occur, policy checks, and say, no, I'm sorry, you need to recertify that this person still works here with this role and affiliation, for example, whatever those policies are. So that's where that can come in handy. Next, we have the value field, which of course is the main thing that when somebody's asking for a specific resource, you're probably looking for various values of a particular visa type. And so you're going to want to match that as a full string. You don't parse it, you don't follow the link, it's a string identifier. Next, we have the source. And once again, you're probably going to want to have some kind of allow list of who is allowed to issue the issuer is above. That's who created the token. But in some more complex cases, you could have one piece of infrastructure that can issue tokens and represent many different sub-institutions, and the source field can point to those different institutions potentially. So depending on the complexity of the environment, the source could be the same as the issuer, or it may not be, and you might need to have a list of who's allowed to issue that. An example could be for, again, for role and affiliation, the issuer could be ELIXIR, but the source might be Cambridge University that says that somebody works somewhere, but they're using the ELIXIR infrastructure to be able to make those assertions. And the by field is after this, and so here it's optional depending on the visa type, but it can also must match depending on the visa type. So for controlled access grants, you probably want that to be a DAC in your policy as opposed to self-issued. And depending on your infrastructure, you say it's not possible to have a self-issued one, that's fine. But depending on the infrastructure and how it's being used, the by field can be useful. Okay, so there's more stuff that can also exist on here. I'm not saying these are all the things that you can ever put inside a visa, but these are the standard ones that we're going through. So just know that there can be more, and you can ignore those if they don't make sense for your policies. All right, now we're going to talk about multiple visas. So I just want to set the background here. There could be two reasons. One is you could have a policy that needs 2 visas. Registered access is one example. So why do we need 2 visas? Well, let's take a look. One can be to certify, like a peer could have made an attestation that Joseph is a bona fide researcher. So that can come from one source stored in one particular system. And on the other side, another attestation can come from the researcher themselves using a different system saying, yes, I agree that I will follow the ethics code of conduct. And a couple interesting things here when you're dealing with multiple visas. One is you have a policy that requires both, but what I want to point out here is that even though we've met the 2 halves of what registered access is, notice that the subject is different, Joseph and Joe in this case. And how do we know that those 2 are the same person? Who decided to put these both in the same passport, and even though they're pointing to different source accounts? So if you can go forward. So that's going to be the major question here, is like, how do we ensure that this actually meets our policies, given the fact that you can chain various brokers together, things can flow into passports. Maybe I need to know who made this decision and how I'm going to trust that this is actually the same person. Okay, another scenario before we talk more about this and the answer is, what if you have a policy that only has a requirement for 1 visa, but it happens to have a visa condition that Mikhail talked about earlier. So it has a condition, an external condition, so it couldn't be something that could encode itself, or we just wouldn't grant the visa. It's something external it can't control. So an example would be a condition being a faculty at Stanford. So if the user has that, and they have an account that says, look, I'm faculty at Stanford, and a system brings that into the passport, once again, even if the subject line matched exactly, and I'm not saying it would, but notice that even if the issuer is different, it does represent a different identity already. An identity is the combination of the issuer and subject. So who brought this in? So both of these things are asking this question, who brought this into this visa, into this passport? How do I know these are the same person? And what's my trust level there? So next slide. So here's the answer. It's the linked identities that Mikhail already mentioned. So we're just going to look at one. So this is the type linked identities, and it's going to have some issuer and subject things at the top. So we can just forward one. So that's the main identity that this was encoded with. So if you trust this particular identity to make assertions for linked identities, this is the entity or the broker, for example, that's making the assertion, that's saying, I'm going to start saying that two different accounts are the same person. So the other identities, which I'm calling identity 2 here, they're in the value field, and they're encoded in a certain way as per the spec. And so here's one identity, and this identity, there could also be more than one. So Mikhail, if you could just forward. So you can put a semicolon and add more here. And so how you would interpret this is, according to identity 1, according to the issuer of this visa, these multiple accounts, these multiple identities are the same person. And so the question you would then ask yourself is, when you see multiple other visas that use different underlying identities, you would then look for a linked identity as well to see who made the assertion and whether you trust that that those two are the same, and that's why they're in the same visa, or in the same passport, I should say. So that's there's more on that in requirement 10 within the passport spec. There's a link in the bottom corner. All right. Whew. All right, so I made it through all the nitty-gritty detail there. Now I just want to highlight one particular thing. There's a lot of really good information on RFC 6819. I know it's a long read. This, I'm going to go through a scary scenario right now, but I want you to know, I'll say up front, this is not something specific to GA4GH or the implementation. This is an OAuth 2 general thing. I just want to highlight it here because it's a very important concept. Let's say you had a network of beacons, and users wanted to do queries to see if their data, if interesting data was in these different data sets. So they're going to basically send their passport to all the beacons they know about, and they get distributed amongst these beacons, and ask, do you have a certain variant at a particular point in a genome sequence? So that's the kind of query, but the problem is that not all these beacons are the same. So if you can forward. It turns out that beacon C is the beacon of evil. It's gone bad. It's a rogue beacon, and it's rogue for one of two reasons, or maybe more. It was either created to be a Trojan horse and like steal people's passports, or it was compromised in some way, and now there's a security breach there that's making this happen. Either way, when passports arrive at this beacon, it will maybe give you a pretend result saying there's nothing interesting, but then it'll make a copy of your passport because you don't have the physical security of a passport that makes it hard to copy. They'll simply start using that passport and calling into other beacons, and that red arrow represents a call that's not supposed to be made. But the other beacon will see it's the user and not the beacon of evil, and it will respond and start using it. Notice that you can have other pieces, other things like DIRS servers or full data sets being stored elsewhere. And this rogue beacon can start using it to access other things that aren't even beacons. And in the end, if you go forward one, you'll see that it can then go get the data and start stealing a lot of PHI. Moreover, it's then going to collect this from more users and get more passports and keep using those permissions to spread wider and wider throughout the entire federated network. And one more. And keep taking more and more data. One more. And there are more services, more GA4GH passport services like search, and you can search across data sets, and you can use all kinds of different services to discover other data sets and try to keep using these various passports and stealing more data. So this is definitely a very bad scenario and one that we need to protect against. Go forward one. So as I pointed out earlier, this is not a GA4GH or passport problem. It's a general thing dealing with bearer tokens and what you need to protect yourself when you're using this kind of thing. It's a little different than we're used to with the physical passports because it's a digital thing that can just be reused. So we got to watch how they get used. All bearer tokens have this problem. Probably how you logged in this morning would have to mitigate this problem too. So this is a very common thing we need to worry about. I'm only highlighting it because it's important for understanding our infrastructure. Okay, so how are we going to deal with this? There's two ways. Either make it really hard to join this federation, to bring in a new beacon or a new service in this network. You got to make it super, super sure that there's nothing that's misbehaving. And even when that's true, when you do all these things, you can still have breaches that occur and you have a massive problem when you do get a breach. Especially in a federated network like this, anyone who gets a virus or some kind of security flaw can compromise the entire network. So it is really hard, even if you try to raise a high bar. We also want to make it easy to join the federation. So that's not a great option. So what are our other options? Or we can do this. We can bind passport access tokens per clearinghouse. So that's the whole point of this particular section 5.1.5.5 is this is really important concept. And so if we just forward one, we'll see how this gets implemented. It gets implemented by adding to your passport a specific audience for that beacon, beacon C. And now if beacon C tries to make those red arrow calls to other services, beacon B will see that it's not meant for it and it will reject the call. So having them specific per instance is a really important way to prevent this attack. There are other emerging standards that can do this that might also help here as well. But this is one I really want to point out is the audience field. But notice how much that can change your infrastructure. It can make it so that you now need different tokens for everything you send it to. And so it implies that it changes the way you think and model your different token allocations. So with that, we should probably go to the next slide. I want to conclude quickly. I know we're running a bit long here. So we looked at the system actors. We have flexible components that can be combined in various ways, multiple sources of visas. We also have OIDC flows where you can actually chain things together, multiple layers of auth that can happen, passing things along as you go. Thin access tokens followed by user info with lots of rich data with visas. The visas themselves can go from encoding different sources of authority, different levels of things, and provisioning of them can be up to the issuer. And finally, the security implications, lots of checks to perform. Maintenance of allow lists are in your domain to do, and identity complexity that we need to manage with those multiple identities and linked identities. And lastly, don't forget all of the underlying security things that all these protocols are built on. OIDC and OAuth2 are doing a lot of the heavy thinking on how you secure these tokens. So there's a lot of work to do there as well. Okay, so here's a link to some useful resources. So if you get the slides later in your email, you can follow some of these links. Some of them are followable where you sit. You can type in some of the bit.ly links. One of the things I want to point out is if you're doing an implementation and have any system requirements, there's a link at the bottom of the slide where you can fill out a form and tell us about what you're doing and what your needs are. Also, if you just have some components you want to share or you've stood up some things that are compliant, feel free to reach out to the DURI or even fill in the feedback form and put that somewhere in the form. So with that, I think we're to our last slide, which is thank you. Thank you on behalf of myself and Mikhail for joining us here today. Went through a lot of information. And wanted to also thank Angela Page on the comms team and Stephanie Lee once again did the slides up to make them presentable for us. So special shout out to them and thanks to all of you for joining. And with that, I think we can open it to questions.
There's some questions in the Q&A section. Thank you so much for that, Craig and Mikhail. It was wonderful. Can you see the Q&A box?
I don't see it at present.
Okay, then I will read them out to you. The first one is from David Pott. He said, if the data is open access and not controlled, this process is not required, correct?
Certainly there's a lot less process involved, so you don't necessarily even need to have logins like identities if it's totally public. You might still want to think about what you want to do in terms of access. So there might be reasons you want to log who's using it for quota reasons or other reasons, but it can make obviously the policies and implementations a lot simpler. So you're right. You can for public data, it could be a lot less onerous depending on your use case. Mikhail, do you have anything to add there?
No.
Okay, great.
Okay, the second question is from Anna, and Anna, I apologize out of respect for your last name, I will not try to pronounce it. She asks, can a user limit a request to specific visas, or does each request end up in returning all visas from /userinfo?
Great question. At present in the spec, it doesn't indicate. So by default, it's like all the visas. In fact, I think there even is a spot in the spec that says return all the visas that are appropriate. I do want to highlight a couple of things here, though. Although there isn't a nice way to ask for one visa, according to the GA4GH specs, there are some underlying specs and even emerging specifications that can say how you can subset things, so that we can follow up with that if that's of interest. The other thing I want to point out that is also the users involved. So the user doesn't have to disclose their visas or not. And some implementations choose to be able to let the user select which visas they want to disclose when they're being requested to ship them between a passport broker and a clearinghouse. So there definitely are options here, but the spec doesn't really indicate a way that you can proceed in a consistent way. You'd have to come up with a way that meets the various standards and use cases.
Wonderful, thank you. We've got one more from Damon. He has a question about the beacon of evil. So in the 5.1.5.5 slide, why can't the beacon of evil modify the auth so it can still contact beacon B?
Oh, good question. It basically comes down to the security of the token. So it's a signed token. So if a rogue actor tries to modify the particular visa or a passport token, it can be easily detected because the signature won't match. And the whole premise is that the encryption keys provide strong enough protection that no actor can try to guess or use a lot of computing cycles to be able to engineer a passport or a visa that makes sense. So only the issuer can issue it. And once it's issued, the signature verifies it's not modified. So that's why the rogue actors can't fake it.
And finally, he also wants to know, how do beacons go bad?
All right. So as I said before, it's possible that someone could just add something to the network. So if we have an open network that just lets beacons come up and register themselves, that's easily a way that a bad actor could introduce something. It's also possible with security vulnerabilities. People can hack into systems and then stand up things themselves, or maybe perhaps even modify how an existing beacon would work. It doesn't have to be a beacon, by the way, any particular service. And so they can go bad through either hackers or just people who are with bad intentions.
Great, thanks so much. That's everything in the Q&A box.
Great, we're a little over time, but thanks again for everyone. Thank you.